From above, the planet appears eerily still. But every mountain range and every chasm on its face is a scar, with many telling a story of when the Earth rumbled to life. Earthquakes occur around the world. They've been recorded on all 7 continents, but most quakes take place in just 3 regions. The Mid-Atlantic Ridge, an underwater line that runs down the Atlantic Ocean, the Alpine Belt, which stretches from the Mediterranean to Southeast Asia, and the Circum-Pacific Belt, which traces along the edges of the Pacific Ocean and is where about 80% of all earthquakes occur. These areas experience the most earthquakes due to what lies beneath the surface. Earthquakes are the result of pressure, specifically pressure caused by extreme stress in the Earth's crust. That stress can be caused by volcanic activity or even man-made activities in certain areas. However, most earthquake-inducing stress is caused by the movement of tectonic plates. Tectonic plates are constantly moving, either against, away, along, or underneath each other. But sometimes their edges may catch and stick. The plates, however, continue to move, or at least attempt to. Energy from this attempted movement builds around the edge's sticking point, creating immense pressure until the edges are forced to let go and the plates slip. This causes a sudden and powerful release of energy, so powerful that it breaks the Earth's crust. This fracturing emits shock waves through the ground and causes intense vibrations, or quakes. In fact, the world's most earthquake-prone regions are where the most geologically active plates meet. Earthquakes, or any seismic activity, are recorded by seismographs. When the ground shakes, seismographs oscillate, drawing a jagged line to reflect this movement. The more extreme the earthquake, the greater the height of the jagged line. These recorded motions are then used to measure the earthquake's strength, or magnitude. While several scales of magnitude exist, the one seismologists prefer is the moment magnitude scale. It has no upper limit, and it measures earthquakes logarithmically. This means that each magnitude on its scale is 10 times greater than the one before it. Unlike the now rarely used Richter scale, the moment magnitude scale can be applied globally and can measure quakes of the highest magnitudes. The largest recorded earthquake occurred near Valdivia, Chile in 1960. Nestled within the Circum-Pacific Belt, the Valdivia earthquake was the most powerful in a series of quakes that struck the region, measuring at a magnitude of about 9.5. In addition to causing devastating tremors on land, the earthquake also generated a deadly tsunami reaching up to 80 feet high. The tsunami raced across the Pacific Ocean, hitting faraway countries like the Philippines and Japan. In fact, data from seismographs show that the shockwaves emitted by the Valdivia earthquake continued to shake the entire planet for days. Some earthquake-prone areas have adapted various ways to protect their communities. Buildings and bridges are designed to sway rather than break when an earthquake occurs. The public is educated on how to protect themselves during a seismic event, and government officials enact drills to ensure the protection of their people. Earthquakes can leave behind incredible devastation. But these same forces have also created magnificent features, with each adding character to a planet so unique.